Okay, there is a chapter number 2, work, energy and power. Very important chapter. Work, energy and power. Okay, so first discuss what is work. Okay, work is said to be done when force applied and body get displaced. Okay, in the direction of force. That's very important. Suppose let's draw uh, some object rest on this tabletop. This is the object. This is the object rest on the any place or tabletop here, and some person A, he or she applied a force. Applied a force in that direction. Which direction? From minus x to plus x direction, left to right direction. Force applied. If now condition is applied, if uh, suppose if the body, this body is displaced. Okay, if the body is displaced, if the body is displaced, body is this very important. If the body is displaced, some like this to there, so here body displaced, and we tell that there is a displacement, that is a d, the displacement. We say the work has to be done. We say work has to be done. Okay, work has to, when the force applied and body displaced. So the basic formula is W, and work is a scalar quantity, force dot or multiply of displacement, F dot D. Okay, and this force is a vector and displacement also a vector. So vector, this is also a vector, and if you multiply these two vector or dot multiplied, we get a scalar. So work done is a work done is a scalar quantity. uh, Quantity. Okay, so that is work done means the force is applied and body gets displaced. Okay, suppose what displacement, there's a unit here. Okay, suppose the displacement is in SI unit, that is meter, 1 meter, and some person applied a force is 1 Newton. We know class 9 physics, so you get a work done equal to 1 Newton times 1 meter. I know the work done SI unit is joules. Joules. Joules equal to 1 Newton, 1 meter, 1 joules. Okay. So there is a very important point. When some persons applied a force, when a person applied a force, if body gets displaced, if body get displaced, body is displaced, and we say the work has to be done. When the displaced body in the same direction, displacement also a vector quantity, you know that if a body displaced in that direction, also minus x to plus x direction or plus x direction, left to right direction, and applied force also the same direction. We say there is a key point here. The applied force, the next page, top pages. The applied force, the key notes point here. Note the applied force, note, and and the displacement are in same direction. Okay, if applied for are in same direction. Okay, uh, if they are in same direction, but some sort of angle may be present. If there's now another condition, if there is an angle, if there is angle. What will happen? What is the angle? Angle between force and displacement. What is the angle? That's angle means the angle between force means applied force and displacement. Applied force and displacement. Suppose I do draw a diagram. There's any boring drawing. So there's a eraser. That's not a straight line. Okay. So that is a straight line. Uh, if we draw a straight line, suppose that a straight line. Okay. Some object down there, that is the object, and some similarly some uh, person uh, person pull the object. Yes, pull that object in that direction. Okay. Some person pull the object in that direction. What will happen? That is a force, applied a force. Okay, that is a applied a force, applied, but the body displays in that case. If elaborate the diagram, some diagram here, the object now displays here, and person in that direction, force here, force applied, and force applied, and body displays. Sorry, the body displays, that is a displacement, the original position and the final position, that's the displacement d. Okay, and that displacement in that direction, the displacement in that direction, applied phase force in that direction. So there is an angle, so there is a angle, this angle is called theta. So theta is the angle between a force and displacement. If theta is the angle between force and displacement, what will happen? So you know that the work done formula W equal to know that F times displacement d, and that is also a vector. Suppose if there is a two conclusion, there is a mathematics and there is a physics, maths told that is a dot product. When we get in class 11, we know that what is dot product and what is cross product. There is two vector multiplication. So two types of vector multiplication, either dot multiplication and the cross multiplication. But here we just skip that portion in class 10. That is not important here. So if a dot d, if mathematically you treat there, so you get a d the cos theta. That is a dot multiplication here. And discussing physics, that is a d cos theta. Theta is the angle between f and d. If f and d both are in vector quantity, okay, this f and d both are vector quantity. Okay, so here we get cos theta, that is theta. So finally we get a work done equal to fd cos theta, or that's this is a mathematics say that these are dot product. Dot product we get a two vector multiplied in dot product we get a scalar, and that is a to b cos theta, like that. If a equal to b vector dot c vector means b c, magnitude of b is here, magnitude of c is here, BC cos theta. Theta is the angle between B and C. Similarly, this of physics, so FD, theta is the angle between force and displacement, and force is the vector and displacement also vector, and here this AD are magnitude. This that is a vector B, that's represent vector B pronounced, and that vector, and that is a more magnitude B. Okay, suppose that is a just a unit. Magnitude means a number, and that is a direction, that represent direction. Okay, so that is FD cos theta. That is a number only. That is a 1 Newton, 10 meter, 1 dyne, 2 dyne, 3 dyne, or that is a 10 centimeter, 12 centimeter, 15, or any other value here. It is a FD cos theta. Okay, now here some condition. Okay, if work done is a positive term, negative term, or a zero term, means is if the boundary condition here, the boundary condition or some condition, what is boundary condition or case number one, when the person applied a force, some person force applied, but the object do not displace. Object, some force may be applied, huge force applied, but the object do not displace. Why object is do not displace means object are in rest, are in rest. When class 9 physics, you know that if force is applied and there is another force is downwards, is called weight. Okay, and weight also a force, that is mg, that is means the gravitational force fg, downward direction. If applied force is less than Fg, means the body are in rest. If applied force is greater than Fg, the body are in motion. Okay, that is a class 9 physics, you know that. Now the case one, if force applied but body doesn't displace or body are in rest. Force applied but body are in rest. That is important. Means no displacement. Means the work done equal to we get if some value 10 Newton, 12 Newton, 15 Newton, any value, and displacement is a 0. And we know that 0 into something, it is 0. There is a 0 joule means there is no work has to be done. If body doesn't displace, but force may be applied. Okay, if force, huge force may be applied, but body doesn't displace, physics say that no work has to be done. If you are doing nothing, if body get displaced, you do something, or some 10 joule, 22, any work has to be done. But if body doesn't displace, means you do not nothing. If a huge force may be applied, but first the very important thing is body must be displaced. Object must be displaced. Object are in motion. Now case number 2. Yeah, simple. Okay? If force is not applied, if force is not applied, very easy condition. If force is not F equal to 0, so work done equal to 0 into D, that is also you get a 0 joule, that is also no work. These two conditions represent no work. Present no work. Okay. Now another three also condition also here. The next condition is condition case number 3. If force some road a flat line, a person walk down the road in that direction, displace walking in that direction, and the person carry some huge object in his head. Fruits or vegetables. Okay, so we know that the weight is downward, weight also downward here, the force, and person displaced in that direction. So know that if the angle between force and displacement, that is 90 degree. Okay, that's important. Angle between force and displacement are in 90 degree. So what does it mean? If a force is downward and displaced in that direction, that is a 90 degree. So we know the work done W equal to FD cos 90 degree. And cos 90 on trigonometric value, that is equal to 0. So FD times 0, that is 0 joule. That's the also another condition for no work. So this now is another condition, case 3. The case 1, 2, 3 are represent the no work. This is another important condition. This is a no work condition. If you carry the huge number, if you carry the 100 Newton weight carry to in your head, but if you disperse in flat road, but physics say that you have no work. If you carry huge lump sum in your head, but in 100 miles you are walking, you are tired, fully tired. Now a huge work has to be done, but physics is said you have zero work has to be done, because if you carry ahead something, that is force, gravitation force also downward direction, and you will displace in flat load, there is an angle between these two also 90 degree. So that is a no work. And another two types of work, if a work is a scalar quantity, but work has a also positive and negative work. There is a positive work or a negative work. Positive work and another is a negative work. So what is positive work and negative work? Very important concept here. So positive work say that a positive work. What is positive work? Suppose um, there is a ladder. Uh, in some person in construction building carry some bricks in your head, in his head, and a person goes upward direction. Person goes upward direction means against the gravity. Okay, upward direction. So the displacement in top, because person goes upward, goes upward means displacement in vertically upward. But the important concept, weight of the bricks, weight of the bricks, weight of the bricks, that is downward. It is a weight. That is equal to Fg. That is downward. So work done formula says that W equal to the force against gravity. That is the against the gravity. Means yes, gravity. Against gravity. Against gravity, Fg or F dash G, say that is times G. Okay, Fd downward and body displaced D in upward. So that the angle between these two, if force Fg downward, but some person applied a huge force against the gravity and goes upward. So displacement upward, if that is a force downward because the gravitation force. But some person overcome this gravitation force in his head and goes upward. The body displaces upward and applied force means gravitation force is downward. There's a gravitation force, and the both magnitude are same. From Newton third law, that is Fg and is against the gravity also the same. Or it's called a normal force. These are the same, but magnitude are same, but they are in different direction. So that is a Fd, and that is a magnitude, and cos theta. Theta is the 180 degree. Sorry. theta is the 180 degree. So we get FGD cos 180 degree. From trigonometric ratio, we know that cos 180, okay, cos 180 is a minus 1. So minus FGD means negative work. If the person carry against the gravity, we get a against the gravity work has some work force person may be applied, we get a negative work. If similar condition, same similar condition, but important is body goes downward. If body goes downward, body goes downward. So Fg also downward. We know that. If displacement similarly the next condition is Fg downward, the person goes down. So obviously person goes down means to the displace here. Person goes down. Complete the work. He or she goes down. So displacement and Fg both are in same direction. So get a work done. Case number 2. So get a work done. So if your work done, case number 2, W equal to Fg goes downward, displace also downward, and that is the angle between these two are the 0 degree. So cos 0 we get a 1. So FGD. So we get a positive 1. Okay. Very important factor. What is positive work and what is negative work? This is a follow the gravity. Follow the gravity. Or towards gravity. Or what? Gravity. Or towards earth center. Against the top case is the against the earth center. Okay. Here is against the earth center. Okay. Clear? What is positive work? What is negative work? And another missing the concept here. The concept is if someone asks in class 10 a board exam, define 1 joule. Maximum number of students here forget definition is wrong here. Define 1 joule. They do not define here. Define 1 joule. How to define 1 joule? Very easy. Okay, there is a two important factor, 1 Newton and 1 meter. What is 1 Newton? 1 Newton force is applied. Where you can force apply? In an object or a body get displaced in 1 meter. Where body gets displaced? In the direction of force. That's an important factor. If 1 joule, define 1 joule. If joule work done, 1 joule work has to be done. 1 joule work has to be done when 1 Newton force applied and body or object get displaced in 1 meter. Another important point is in the direction of force. In the direction of force. That's very important. In the direction of force. Similar concept. The force apply and body dispersed in that direction. Both are in left to right direction. That's very important. Both are in same direction approaches. Okay, that is the definition. If you forget that line in the direction of force, the answer is wrong, 100% wrong. Because there is a very important force applied body dispersed in another direction. Obviously, there is also positive or negative but important. But in the direction of force is very important. If you ask uh, the direction of force is different. Okay, if work done is downward and body goes upward, so there is a difference here, because work done is downward force, that is a not a follow. These are direction of force. Yes, they follow, because the person goes upward from Newton third law, that is normal force. Normal force, that is also equal to the weight. The magnitude are same. The magnitude are same, but the against the gravity work. That's very important. Say that the against the gravity. Okay, that's why it's very important. And in that case, both are in obviously same direction. Okay, very important point. The body displays in that direction. Okay, point of application. So that is a basic concept of work done. Okay. Next class is discuss on some special cases, or some discussion of what is the variable work done, or what is the energy related to work done. Okay, unit of work done and power. Okay, and there's a difference of the kinetic energy, potential energy versus work done, and what is the energy. So we complete the lecture here. If you have any doubt, put in comment section. Thank you.